Okay, so I had to stop there. So we're going to start up with question number 31. So for question number 31, it says that books in the county library are found to have an average length of 350. So that means our average or mean is 350. And it has a standard deviation of 100. And if the z-score for a copy of Kafka's Metamorphosis is negative 2.7, what is the corresponding number of pages? So again, we're still going to use the same formula up here. So I know the z-score is negative 2.7, and I know that the average is 350, and the standard deviation is 100. So then what I want to do is I want to solve for x, so I'm going to solve it algebraically. So I need to get x by itself, so I'm going to first get rid of the 100. Since it's dividing by 100, I want to multiply both sides by 100, and that will cancel. So then I'm going to do negative 2.7 times 100. Let me do that over here. So then that multiplies to negative 270, and then equals x minus 350. And then to get x by itself, I'm going to add 350 to both sides. And so then x would be 80. Okay. All right, for question number 32, the average rainbow trout in Shaver Lake weighs 3.5. with a standard deviation of 1.1. The average weight, so this is the trout, let me do that, RT, rainbow trout. And for the largemouth bass, its average weight is 5.4 with a standard deviation of 0.9. So Michelle catches a 2.2 rainbow at Shaver, and Eddie catches a 4.1 bass at Pine Flat. So relative to the other fish in the lakes who had the better catch, and assume the distribution is normal. So since we're not comparing apples to apples, we have to find their z-score and see who has a better z-score. So we're going to start with Michelle. And so for Michelle, the z-score, so I'm using the same formula up here, right? So Michelle's catch was 2.2, and minus the average, which is 3.5, divided by the standard deviation, which is 1.1. So then I'm going to go ahead and work that out. So that was negative 1.18. So Michelle's z-score is negative 1.18. So she's below average by a little over 1 standard deviation. And so now for Eddie, so let's do Eddie. So for his z-score, so Eddie's catch was 4.1 minus the average bass, which is 5.4. divided by that standard deviation, which is 0.9. So then Eddie's z-score was negative 1.4. So Eddie's catch was also below average, and it was more below average, right? So he was negative 1.4 below average, whereas Michelle's z-score was negative 1.18 or 1.2. So then who had the better catch would be Michelle, because even though she was still below average, she was not as far below average. Okay, and then question number 32. So this is a frequency distribution table, and for the number of cars registered in each household, show the 5-number summary for the data, find the mean and the mode, and then convert the table into a histogram. So let's just do the mean and the mode. So, so I have 0 cars, and then I have twice, right? 0 cars twice, and then I have 1 car 5 times. And then I have 2 cars 7 times. And I have 3 cars 4 times. 4 cars once, and 5 cars once. Okay, so there's my list of data. So, oh, I think I said I was going to do the mean and mode. I was going to do the, all right, let's go ahead and do the average. So to find the mode, so the mode is the most, so you have 7 2-car families, so 2 would be the mode, because you have the most of those, right? So there's my mode. To find my average, I would add up all the numbers and divide by however many I have. So I can go ahead and just like add up all of these values, right? Like that, or I can just say, okay, this would be, I have 2 of these, right? So that would be 0 times 2, so that would be 0. 1 times 5 would be 5. 2 times 7 would be 14. Let me do this underneath. So 0 times 2, right? And then 5 times 1, because I have 5 ones. And then I have 7 2s. And I have 4 3s. 1 4, 1 5. And then I just need to add up all of those numbers. Or I can just add, right? I could do 1 plus 1 plus 1 plus 1 plus 1. So if I add up all those numbers, I get 40, or if I do the little shortcut, I also get 40. So there's my total. So to find my average, I do my total divided by however many I have. So my total was 40, and then I have altogether 20, looks like. So 5, 6, 7, 14, 18, 19, 20, right? Or I can count them 1, 2, 3, 4, hey, 20. And so then my average would be 2. Okay, and it makes sense that it's 2, right? If I look at the distribution there. Okay. All right, and then I'm not going to do the 5 number summary because you guys should know how to do that. So my low would be 0, my high would be 5, and then I would count 10 in, and then my median would be 2, right? And then quartile 1 would be 1, and quartile 3, or yeah, would be 3. Alright, so for 34, the number of text messages sent on a particular day for a group of students listed below, you want to make a stem and leaf plot and then figure out some percentiles. So I'm going to put this in order first. So I'm looking for my values. So I have 22 and 23. Oops, I missed a 16. And a 26. 31. 32. Okay, so they're in order. So now I'm going to do my stem and leaf plot. So I have 16. And then in the 20s, I have a 22 twice. And I have a 23 and a 26. In the 30s, I have a 1, 2, and a 6. And an 8. in the 60s, and then in the 70s, and then in the 80s I have a 2, 4, and an 8, and in the 90s I have a 90. Okay, so there's my stem and leaf plot. So now for my percentiles. So for my 60th percentile, I'm going to do 60th percentile, so 0.60, times the number of data values I have. So I have 1, 2, 3, 4, 5, 6, 7, 8. So I have 15. So times 15, so I'm going to do 0.60 times 15, which is 9. So whenever I have a whole number, I add 0.5, and then I'm going to average the 9th and the 10th. So I count in 9.5, so 1, 2, 3, 4, 5, 6, 7, 8, 9.5. So 9.5 is in the middle, so I want to average. So then that means I need to do, for the 60th percentile, I'm going to do 38 plus 61 divided by 2. So that would be 49.5 is my 60th percentile. And then for my 75th percentile, I'm going to do 0.75, that's fine, times 15, because I have 15 altogether. And I get 11.25. So if I have a whole number, I add 0.5 and average. If I have a decimal, I always round it up. So I don't round it, I round it up. So that means I'm going to count 12 in now. So this is counting 12 in. So my 75th percentile would be 82. Okay, so I do my percentage times how many I have. I got a decimal, so I round it up to 12, we count in, and the 12th number is my 75th percentile. Okay, last one. So each letter represents 5 units of measure on the x-axis. Select the best value that represents the following graph. So when I look at this, I should see that it's kind of like a normal distribution, right? And so my mean would be here, and then I know that as I go over, right, I'm adding 1 standard deviation. So this kind of looks like this is over 1 standard deviation, right? So I need to figure out, well, how much is that value, right? That's what I'm trying to figure out. And so because they say that each letter represents 5 units of measure, that means we're counting by 5s. So like this is like 5, 10, 15, 20, 25, like that, right? So if we're counting by 5s, that looks like this has got to be around 5 units, right? So if it's around 5 units, my standard deviation needs to be around 5. And so the only standard deviation that makes sense then is C. And that's it for the review.